Hello, welcome back to POE. Today we're going to be discussing VEX Robotics Platform and ROBOTC Software. Essentially, this is what we call the test bed. We're going to be constructing this here in class today, and we're going to be using this to learn how to program a multitude of different functions. This is going to be a brief with the VEX Robot Platform, and in here you're going to see we're going to a lot of this VEX stuff that we've already been discussing, or not stuff, but the VEX hardware. We'll be using these components which make a robot move. Gears, weights, servos. We're going to be discussing these. Motors. There's two different types of motors. First of all, we have a 2-wire motor called 269. It goes through motor ports 1 and 10, ports 2 through 9 using motor controller 29. We also have a 2-wire motor called 393. The next thing we're talking about here is servos. It's similar appearance to the 3-wire motor, but it's a very different operation. A servo is going to rotate 0 to 120 degrees. It will not make a full turn. You can also set the motor at a power value. A servo is set to a position value. On this, telling us the different degrees. Negative 127. The computer automatically sets it, has a number that it refers to as negative 127. It's a value and all the way to 0 degrees. Now, as we want to move it, 127 is this range here of 254 numbers to move at 60 degrees one way. And what I want to describe this servo then is you've got this 60-degree angle approximately, and made a 30-degree. All right, the subsystem. There's all these different inputs that sense the environment. We have what's called a bumper switch. Right here's our bumper switch. We've used this when we did our bridge project. We have what's called a limit switch. This right here is a limit switch. A line follower. This right here is, where is our line follower? I believe this right here is the line follower. An optical encoder. I think this right here is our optical encoder. And then this right here is the one that is ultrasonic. One of these two right here. One of these two is the ultrasonic one. Not 100% sure. Alright, potentiometers. How it works. It's an analog sensor. It measures the rotation of the shaft between 0 and 265 degrees. Cortex returns values between 0 and 4095. What you have here in the middle is this thing right here in the middle is going to spin. Alright, this right here can spin. And as you set it to different degrees, this is kind of like a, in your house you might have a resistor, or not a resistor, but a light switch that spins and it turns the shaft, turns the lights on dimmer. Called a dimmer, I guess, dimmer switch. There we go. And a potentiometer is much like this. Alright, you can turn it to different degrees and it will make different things happen then. Internal mechanical stops prevent potentiometer from turning a full revolution. Excess torque against the internal mechanism stops and will cause them to wear. Quadrature, the Quadrature shaft encoders. How it works. Digital counting sensor. It's used for counting. Inner shaft spins as the encoder counts, and it basically just counts numbers of revolutions. Ultrasonic. Similar to how bats and submarines sense distance, this right here is used for finding distance. If you want to set your robot to be able to go a set distance from a wall or something, this is what you'd be using. Essentially, here's how it works. You have this robot, and it sends these rays, these ultrasonic waves out the front, and it senses how close it is to an object. Works a lot off of echo. We have the VEX Cortex controller, and then we have over here is the VEX Cortex controller. This is basically the brains, or the operating. It runs. It's not really the brains. It's where you're going to store all the operating software. ROBOTC developed specifically for classrooms and competitions. Complete program solution for VEX Cortex and several other popular robot platforms. It's has a real-time debugger, and it's similar to industry standard C programming. So that's this ROBOTC software that we're going to be downloading. Industry standard skill sets. Java and C++, along with Eclipse and Visual Studio IDS, have been used to program. As you can see, we've got all these different items here that Java and C++, the same programming you're going to be learning, is the same program or very, very similar to all of these in the industry. Robot start page. Here's where we'll be starting. Displays the latest ROBOTC versions of ROBOTC and robot resources. It's not going to be highly interesting to you, that first page. All right, platform type allows you to toggle ROBOTC programming mode between Vertex PIC and Vertex Cortex, which will enable features and commands for the system. What you're going to do is you're going to want to come up here to robot, go to platform type, and we always want to go to innovation first, and go over here to the natural library VEX Cortex. Alright, we are going to be using the Cortex because the main brain is a Cortex operating system. I don't know if it's a Cortex operating system, but we call it the Cortex because it's that type of programming. Over 75 ROBOTC sample programs organized by robot behavior. It's got lots of sample programs that you can pull up. We won't be using any of those, maybe one. Comments are used to make notes in code for the human programmers. Every sample program contains comments pertaining to robot configuration of ROBOTC, commands, robot behavior, etc. Single line comment. All material after the / is ignored by the ROBOTC compiler. Multi-line comment. All material between these marks right here, all material between these marks is ignored by the ROBOTC compiler, and it's always going to be, comments are always in green. Alright, ROBOTC Help. In-depth explanations about ROBOTC interface, commands, and debuggers. Main menu level. Alright, there's several different. We're going to be doing almost everything to start off with right here on this basic. We won't get to expert for quite some time because we're just not going to be good enough at it. Motors and sensor setup. Alright, this is going to be something that we have to go into every single time to make sure that all of our sensors are set up right. It's kind of like a calculator. If you put garbage into the calculator, you're going to get garbage results. If we don't program ROBOTC to do exactly what we want it to do, it doesn't know to do anything automatically. It's just a machine. We've got to program it, and part of that programming is making sure that our sensors are plugged into the right spot, and we're telling our Cortex exactly what we want it to be, where we want those parts to be. The Cortex, which was right here, was our Cortex. Our Cortex, again, we have to tell it exactly where things are plugged in. Alright, here we go. VEX Cortex download method. Well, it allows you to specify how programs are downloaded. Whether Cortex looks for VEXNet connection when it starts up, allows you to download using VEXNet or USB. However, the Cortex will look for a VEXNet connection for up to 10 seconds of running code. This right here is under Robot. It's VEX Cortex download method. And again, here we're telling it to look for the VEXNet or the USB. Download USB only. And you'll understand what this VEXNet is later, but basically allows us to go wirelessly. Well, hey, that's been it for today. I'll catch you on the flip side.